So here is our related rate summary. All right, step number 1. Read the problem and draw your picture. And be really precise about what you want to find. So state specifically what you want to find. Once you've read the problem and drawn the picture and stated what you want to find, identify any rates that you are given.
Is it still part number 1?
This is going to be 1.5.
Okay.
All right, so step 1 is to read the problem and draw the picture and state what it is that you're trying to find. So we're trying to find something that's going to be a rate of change of something. Now, chances are really good that you're going to be given another rate of change in the problem. Okay? And so you're going to have a variable that'll be d law over dt. That's the one you're trying to find. And you're probably going to be given d squawk over dt. Okay? All right, so you're trying to find a rate of change of one particular variable. You're given a rate of change of a different variable. Step 2 is to state as an equation a relationship valid at any time among the variables above. So among the variables where you're given a rate of change and where you're trying to find a rate of change. Okay, so state as an equation a relationship valid at any time among the variables including squiggle and squawk. All right, step 3, differentiate with respect to time. So we're going to take that equation and we're going to differentiate with respect to time. This gives us a relationship between the rates which is valid at any time. All right, now I'm going to put a star on 3, and the reason I'm going to put a star on 3 is that when we write down our relationship in 2, and our variables are including whatever variables we have, we want to think of each and every one of these variables that we have here as functions of time. So anything that changes while your movie is going on in your head, anything that's changing is a function of time. And that means that when we take our derivative with respect to time, you have to use the chain rule. Okay. So the star on this is to remember to use the chain rule when you're differentiating. Okay. All right, and the last step, once we've come up with that relationship, we've differentiated both sides, then in step 4, now introduce any sort of specific values which our variables take at the instant in question. and then we can solve for what we're trying to find. All right. So these are our related rates type questions. All right, are there any questions about this? Okay, so the hard part, the part that becomes challenging on these problems is exactly, Arthur, what you were saying, which was you looked at the initial problem and it didn't quite make a lot of sense. Things didn't quite add up properly. And so the hardest part, in my opinion, about these related rates problems is drawing the picture and coming up with step number 2, which is state an equation, as an equation, a relationship valid at any time among the variables that include both the variable that you're trying to find the rate of change of and the variable that maybe you're given the rate of change of. Okay. So that is going to be the hardest part about these problems. Okay. So I'd like to give you some practice problems out of this section. Take a look then.